Hey y'all, so I know I'm not in class today, but I still wanted to talk about systems of equations and special cases. There's two kind of cases that we are going to cover today in class. One of them being no solution, the other being infinitely many solutions. This is pretty similar to what we worked with in summer school when we were just solving multi-step equations without two variables. So now that we're in two variables, obviously we're working with a system of equations. But basically what happens is when you have a system that has no solution, if you were to graph it, what it looks like is you have two parallel lines. So remember, with the system of equations, you're always looking for where's the intersection of those two equations, and that's your solution. Now, being that it's no solution, it means that they're parallel lines, so those lines never intersect. Now, once you work through a problem and you go to solve it, in this example I solved it by elimination, I got a false statement down here of 0 is equal to negative 10. That tells me that I have no solution. Now, on the other side of things, I could also have infinitely many solutions. What that looks like if I was to graph it is that you would have two lines on the exact same spot. So you would graph one line and then you would go to graph your second line and it would be the exact same equation. So every point on each line they would be intersecting at. That's why it's infinitely many solutions. Again, this one I actually solved by substitution, you can see here. So I plugged 3x plus 4 into my equation, and I got 16 is equal to 16, being that it's a true statement. That tells me that I have infinitely many solutions. Now, those are the notes that you're going to copy down in your notebook. There's some guided practice here that I have for you guys that I'm going to work through. I also have a couple practice problems attached in on campus. So this first one here, I'm going to do this by graphing just to show you what it looks like. So the first one I'll do in red. My slope is negative 3/4 x. My y-intercept is a positive 1. So I start at positive 1 and I go down 3 and to the right 4. I'm also going to go up 3 and left 4 to add as many points as possible. Connect the lines just like so. Even add arrows at the end. Second one here, I'm going to do this in blue. So negative 3/4 x plus 3. So m equals negative 3/4. My y-intercept is a positive 3. That starts up here at positive 3, goes down 3 and to the right 4. I only have 2 points because if I go up 3, I'm off the graph. So my graph looks something along these lines. Now, you may notice right from the beginning that you have the same slope. Anytime you have two equations with the same slope, by definition, it means that they're going to be parallel. So notice that there's no intersection in between here. It's not hidden. It's not like you're going to see the intersection way off the graph here. There is no intersection, so it is no solution. Now, same thing in this other example over here. I just happen to put it into not slope-intercept form. So I'll work through this first example, putting it into slope-intercept form. So if it's x minus y equals 2, let's subtract x on both sides. We have negative y is equal to negative 1x plus 2 divided by negative 1. I get y is equal to positive 1x minus 2. It means my slope is 1. My y-intercept is at negative 2. So I start down here at negative 2, and I go up 1, right 1 each time, like so, and then go down 1, left 1 as well. Connect the dots to make your line. There's my first one. Second one, again, I'll do this one in blue. It's a similar equation, just a little bit different. X minus y equals 1. Let's subtract x on both sides. Negative y equals negative 1x plus 1 divided by negative 1. We get y is equal to positive 1x minus 1, where again my slope is 1. My y-intercept is negative 1. So I start here at negative 1, and I go up 1, to the right 1, down 1, left 1. Connect the dots here. Now again, notice in between, there's no intersection between our lines. they have the exact same slope. The slope is 1 for both of my equations. So because there is no intersection between those lines, it means that we have no solution. I didn't provide an example of infinitely many solutions because as I graph it, it would just look like the same line on top of the other one. But we'll have an example down here of infinitely many solutions. Now I'm going to solve this by substitution. I just wanted to show you all the methods here today. So this one, I already have the second equation where I get y equals x minus 3. So it's already set up into the form where I could solve by substitution fairly easily. So I'm going to take x minus 3 and plug it into y in the first equation. X minus, use parentheses, x minus 3 equals 3. Remember, there's that ninja 1 that's hanging out there. So I'm going to distribute into my parentheses here. X minus x plus 3 is equal to 3. Combine like terms. X minus x is 0x. Don't even worry about the x's anymore because they cancel each other out. So I have 3 is equal to 3. That is a true statement. Now notice there are no more variables for me to solve for. I'm not solving for x anymore. I'm not solving for y. Everything canceled itself out and I got a true statement. That means we have infinitely many solutions. If you get a true statement, it means you have infinitely many solutions. Any value for x and y that you plug in to both equations would work out the same way. Same thing over here. The only difference is that now I have to set up one of my equations to be in y equals or x equals. I'm going to take this second equation down here and turn this into y equals. So let's add 7x on both sides. I get y is equal to 7x plus 8. Let's plug this in for the y in the first equation. So 14x minus 2 times 7x plus 8 equals 7. Distribute the negative 2. 14x minus 14x minus 16 equals 7. The x's cancel each other out, so I'm left with negative 16 is equal to 7. That is false. Negative 16 is not equal to 7, so because I got a false statement, it means I have no solution. So there's two examples, infinitely many solution and no solution when we're talking about substitution. Let's see elimination. And again, I think this is going to be everybody's favorite way of solving. It is one of the faster ways here. 5, I have x plus 2y is equal to 0, and negative x minus 2y is equal to negative 4. It's already set up because I already have my opposites and all my variables are lined up. The x's on top of the x's, the y's on top of the y's, and my numbers over here on the right side of the equal sign. So, add together because we have opposites. X plus negative x, well that cancels out, so that's 0. Then I have 2y minus 2y, that again is 0, so I'm going to leave 0 over here on the left because everything's canceled out, and then 0 plus negative 4 is negative 4. All of my variables have canceled out. There's no more x's and there's no more y's, but I've come to a false statement. And because we have a false statement, it means that we have no solution. Let's see another example. This one I'm going to have to multiply one of my equations, I bet. So negative 12x minus 8y equals negative 16, and 6x plus 4y equals 8. It looks like on the bottom here, I can multiply this one by 2 to create a pair of opposites. So that becomes 12x plus 8y equals 16. This top equation is going to stay the same at a negative 12x minus 8y equals negative 16. I didn't need to change that at all. However, I have pairs of opposites. My x's are opposite, so those are going to cancel out. My y's are opposite, those are going to cancel out, so I'm left with 0. And then negative 16 plus 16, again, That cancels itself out. That becomes 0 as well. 0 is equal to 0. That's a true statement every time. So that means we have infinitely many solutions. And then one more example. This one's a little bit more, but still pretty straightforward. All my variables are lined up. I have my x's on top my x's, my y's on top my y's. So here I have to multiply both equations to create a pair of opposites. It looks like for this top equation here, I'm going to multiply this one by 8. And then this bottom equation, I'm going to multiply this by -10. The only reason that I chose to go with +8 and -10 is because both of these signs being the same here, a -10 and a -8, I need opposites in the x. So I have to multiply one equation by positive and one equation by negative. So after multiplying, I would have -80x minus 320y equals 240. And then for the bottom equation, I would have a positive 80x plus 320y equals -240. I think you guys can already predict what is going to be happening here, because once I add these two equations together, my x's cancel, my y's cancel. I get 0 on the left side here. 240 plus -240 is 0. 0 is equal to 0 is a true statement, meaning, again, that we have infinitely many solutions. So that is what it looks like when we have some special cases when we're talking about a system of equations. Now, normally, for the most part, you will always have problems that have an intersection where you solve for both x and y. That will happen a majority of the time, but you could have a couple cases where you have no solution or infinitely many solutions. So make sure you subscribe to my YouTube channel, hit like. There will be some practice problems for you in your assignment center. Good luck, and I will see you in class.